Today we're looking at section 3-4 on measures of relative standing and box plots. Our learning outcomes are as follows. Number 1, determine the z-score for a data value and explain what it means. 2, use z-scores to determine when a value is unusual. 3, find the percentile or quartile of a given value, data value. Find what percentiles and quartiles are. Actually explain, not find. Find the 5-number summary for a set of data. Draw the box plot and or modify box plot for a given set of data. Okay, the first measure of relative standing that we study is what's called the z-score. The z-score tells you how many standard deviations above or below the mean the given value lies. A positive z-score would mean that the data value is above the mean or greater than the mean, and a negative z-score would mean that the value is below the mean or less than the mean. And for a sample, the way we calculate, trying to get my pen working here, the way we calculate the z-score is we take the data value x minus the mean x bar and divide it by the standard deviation. For a population, we find the z-score by taking the data value x minus the mean mu. Remember, for a population our mean is mu, divided by little sigma, which is our population standard deviation. So you can see the process is exactly the same. A z-score should be rounded to the nearest hundredth, that is 2 decimal places, because of the fact that later on we'll be using a table of z-scores, and those values are always rounded to the nearest hundredth. Now, interpretation of z-scores. Usual values are z-scores that are between -2 and 2 inclusive, so we are including the -2 and the +2. Unusual z-scores would be those that are less than -2 or those that are greater than +2. So z-score is our first measure of position. Okay, and it's relatively easy to compute. Now, next we look at what are called percentiles, deciles, and quartiles. When working with a set of numbers, we can divide the list of numbers into 100 pieces using 99 percentiles, into 10 pieces using 9 deciles, or into 4 pieces use 3 quartiles. Notice that the median is equal to the 50th percentile, and this is the way we designate a percentile. Capital P with a subscript. That's the 50th percentile. 5th decile is also the median. 2nd quartile is also the median. So the 25th percentile separates the bottom 25% of the values from the upper 75% of the values. Note that the 25th percentile is the same as the first quartile. So my question is, what would be the quartile representing the 75th percentile? Correct, it would be the 3rd quartile. Now, where you usually find these values is when you take a standardized test. Very often the scores are given in terms of percentiles. Also, if you have a child and you take the child to a doctor, the child's height and weight will be scored as a certain percentile. For example, when my daughter was little, she was in the 10th percentile. And if you know me, I'm very short in terms of her height at when she was very, very young. This is like as a toddler, which means she was in the only 10% of babies the same age as she was were shorter than she was. 90% of the babies at her same age were taller than she was. Now, as she grew later on, her height increased, and she's probably closer to about the 50th percentile now. But as a baby, she started out very short. She was a preemie for one thing, so that may have affected her height. All right. right, now what do we do when we're working with a set of data values? Well, we have two processes that we need to be able to do. We need to be able to find the percentile ranking of a value x, and we need to be able to find the value x that is at a given percentile. So what I have here is a list of the scores on I believe it was on a test. Let's see. So I have a series of questions that we're going to answer on that. But first let's read how we go about this. To find the percentile ranking of a value x, we take number of values less than x and divide it by the total number of values. Then we multiply that answer by 100 and round to the nearest whole number. So we would express that as a percentile. So we could use the capital P, like if it was at the third percentile, it would be capital P sub 3. If we're trying to find the value x that is at a given percentile, we divide the percentile number by 100 and multiply by the number of values in the list. If the result is not a whole number, round it up to the next largest whole number. Count to that value in the list. If your result, and that's going to be your percentile value right there. Count to that value in it. If your result is a whole number, your answer will be halfway between that value and the next value. And here's our formula. L, it's called the locator formula. L equals K over 100 times N. So we're going to use that information to answer these questions. So number one is find the 72nd percentile. Okay, so that's this type of problem. That means we want to do this. So we're to find P sub 72. So we want to use our locator. 72 over 100 times, let's see how many scores we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 23, 24. Now, I have a tendency just to go with the decimal simply because it's easier to enter in the calculator. So when you're saying 72nd percentile, you're talking about 0.72. So I'm going to turn my calculator on and multiply 0.72 times 24. I get my locator is 17.28. Now, since it's not a whole number, we go to the 18th value in our list. Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I believe that's the 18th. So we find that our answer for the 72nd percentile is 96. So notice locator is not your answer. That means just to go to that value in your list. Okay, P sub 36. So I'm going to kind of shorten this a little bit. .36 times 24 is 8.64. That means we go to the 9th value in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that one, the answer is 80. All right, we're to find the first quartile. Okay, the first quartile, remember, is the same as the 25th percentile. So 25th percentile. And I think this is going to give us 6. Okay, so we got a whole number. So this time we want 1, 2, 3, 4, 5, 6. We want to go halfway between the 6th and the 7th value in the list. So between 6th and the 7th. And since they're both 80s, it would be 80. All right, or to find Q sub 3, third quartile. So this would be the 75th percentile. I think it's going to be 18. So that's going to be between the 18th and the 19th. And here we had the 18th, so it's between 96 and 96. So our third quartile is 96. Next we want the 4th decile. As we move to the 4th decile, get my list back here. Okay. Alright, so decile 4, that's 4/10 or 40 hundredths. I'm going to use 4/10 times 24 would be 9.6, so we want to go to the 10th number in the list. 3, 4, 5, 6, 7, 8, 9, 10. So that's 88. That's our locator calculations. And our last one of this type, 9th decile. Our locator would be 9/10 of 24. So 0.9 times 24 is 21.6. So it's going to be the 22nd number, which is going to be 100. So that's how we use the locator formula to find a given percentile, quartile, or decile. Now we're trying to figure out the percentile ranking of the number 76. And let me erase my